Okay, cool. Am I sharing my screen? Okay, load balancer. That's the only topic that we will discuss today. Load balancer plays a big role when it comes to scaling. Like companies uses companies they need to scale, and there are two ways to scale. First one is you can rent a bigger server, and then that can handle more transactions. So that's what a scale up is. But then the issue with the scale up is you will hit to, okay, maybe I can just write it down here. Scale up issues. So first thing, what would happen is you will hit the limits. Because the maximum server you can get is, like, there's a maximum. There isn't a server that has unlimited CPU, RAM, or hard drive. There's no such thing. So you would hit that limit. First thing is it's could be more expensive. Like one powerful server costs, so like you want to have 4 GB, like not 4, but having smaller servers will cost less than the bigger one. So scaling up issue. So scaling up means making your server or resources bigger in terms of CPU, memory, and etc. So there is a limit, more expensive. And now, if you have one big server, then now you have one. There is single point. If that fails, then everything is down. Single point of failure. So if the server goes down, you lose everything. Okay, these are some disadvantages of scaling up, and that's why people do scale up. Also, issues step up. Scale up is recommended. Okay, when it comes to scaling, so when I talk about the scale, so you just think about scale out. Instead of making your server bigger, just add more servers. And all those many servers running the same application. And one thing I want to elaborate on this scale out, that serverless services support scaling out by default, and it's managed by AWS. So basically, today, this what we are learning in this first block is IaaS model. So we manage our resources. In that case, as you remember in the first slide, you have more things to manage. And one of the things on you, that is on you to manage is this is scaling. You do it yourself. But when you use Lambda, when you use services like Lambda, it can scale out by itself. You know the number of times it scale out. So that's some introduction. So again, this load balancer is not, but load balancer now plays a big role when it comes to scaling. So now let's think about this. Here we have servers, bunch of servers, smaller servers, are running the same app. So I could set this AMI. So even I can call it my custom AMI. So this is where our app is. So basically, this is where our app is hosted, where our app is configured. So there is its dependencies runtime, configuration, all the things we did this in the custom. So from this custom AMI, you can create this n number of servers for scale. So now there's 4 servers. This is EC2. So there's many servers running the same application, and now it can deal with better. When it comes to scaling, it's better. So it can handle many transactions. Now you might be wondering, now this has, you can put some IP addresses there, but then now you have like 4 different IP addresses. And then maybe then that's something that you then have to do on your client side. I don't know, like it's hard. Like you need one gateway, one entry point to your application. So basically we need something in front. Something in front. Like that is how your clients will access your applications. So you just need your one URL, maybe api.app.com or api.app.com, and then that will hit your applications. So that's when this load balancer comes into the picture. Load balancer. It's like a gateway to your application. So now you have one URL to all your servers running the same app. Makes sense? So this is like api.example.com. Same thing, api@example.com. You use this, then it would hit your application running in many servers. And then what it does is it distributes traffic equally. So if there is a 100 requests at a time coming to your application, then it would make sure that one of the server is not overloaded. It would make sure that it would distribute this traffic equally. So it's here. So these are it plays a bigger role when it comes to scaling. Also, it becomes an entry point to your application. And there is one big role that it also plays a big role when it comes to fault tolerance. So now what happens is that load balancer, it knows if this instance is healthy. So for example, if the third instance, like somehow there is something went wrong and this guy is no longer this third server, there's something wrong. So it's offline. In that case, load balancer would know that, it would get that information, and then it would make sure that new transactions are always routed to healthy instances. So it would be routed to here, 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 but not this one. So now you can make sure that there is one entry point there, and all those client requests are routed to healthy applications. Yes.
Now we have single point of failure.
Load balancer, it doesn't fail. It doesn't fail, and it can deal with hyper performance, and it can deal with millions of transactions per second, and it doesn't fail. It's managed by AWS. It's kind of like, it could be expensive, by the way. Like when you have this, when you have a smallest load balancer, you have to pay about $20. And then if that gets bigger, it's kind of expensive, but again, it doesn't fail, guaranteed.
But can we have more than one load balancer?
By the way, yeah, that's very good question. I like your question. So you create one resource here, load balancer, but when you create load balancer, you select ASIS, like how many data centers you want to create its nodes. So it's one logical instance, but if you click on that resource, you will see which data centers these load balancer nodes are working. So this load balancer consists of multiple nodes in different ASIS. So they even ask you to select at least 2 ASIS for high availability. You can also set like 6 other ASIS if it's mission critical. It's up to you. And then it's one very important point. So for example, this is one AZ 1A, 1B. So it's A, B. So you select the A and B. Let's say that the second instance is running in UASys 1C. In that case, there is no way to route this traffic because there is no such NLP node there. That means like if it's all the instances, it has to be either UASys 1A or 1B.
So, Professor, if we add any other EC2, like if we decommission any EC2 or add a new EC2, will it get updated in load balancer automatically, or do we need to configure that?
Exactly. So it will be automated. It will be added automatically. So for today, it's part 1. So we will manually register instances, but tomorrow it's part 2 that we will add and remove instances automatically. So that's what this like scope of today. So what I'm drawing now is it's for tomorrow. So you create something called here. Okay. You create something called auto scaling group. So how it is scaled is, it's based on the metrics. For example, CPU utilization. Okay. If CPU utilization is more than 70%, then you want to add one more resource. If CPU utilization is less than 10%, then you can remove one of them automatically. So, and then CPU utilization metric that I forgot. That you have this, like if you select the EC2 instance and click on monitoring tab, and then you will see CPU utilization metric is there by default. But that's pretty much all. It's about today and tomorrow. We will look into this. This is the high level picture. You can understand then that it's very good. And now what we will do is just deep dive into, and we will see how it's done in the console. Okay, give me 1 minute to log into my console. Okay, load balancer, it's a tool that distributes incoming traffic equally across multiple EC2 instances. So not only EC2 instances, you can run it in front of other services as well. You can run it in front of Lambda or container service. Like it's not specific to EC2. And it enables fault tolerance that I told you how it improves that, because it knows if services are healthy and it only routes traffic to the healthy services. if there is no of this instance, then your load balancer will not even work. It will just hang there. So it helps prevent one server from being overloaded, and while another server can handle more visitors. And it makes your application more reliable. There's something I mentioned. It helps you to scale out. And it's a gateway that you would receive one URL for all your servers running your application. And it improves fault tolerance because it knows the instance is healthy or not. And let me show you how. And in AWS now, there are 4 types of load balancers. 2 of them are important and used 99% of the time. So I will talk about those 2 load balancers. It's the same thing. It's the same thing, but the details are a bit different. So I will elaborate. The first thing, the most popular load balancer is known as application load balancer, ALB. And I will give you some details about that ALB. And then when I talk about the next type of load balancer, network load balancer, I will just simply compare that with the existing one. The details are a bit different. And then all these different type of load balancers, they operate all on different OSI layers. And then I will talk briefly about OSI layers, just refresher, and then start talking about these different types of load balancers. So anyway, okay, let's just start with load balancer. Okay, let me cover this OSI layers first. So this is important because you can take a look at here. We have these 4 types of load balancers. Network load balancer. This is the most performant load balancer. The reason why it's more performant is because the OSI layer that it operates at. So it operates at OSI layer 4. So OSI it's a model that how your data is transformed and transported over the internet, like your text. So it becomes bits when it is transferred over the network. And how this text is transformed into bits is following these 7 layers. And application load balancer, this is what I will demo now. So this operates at layer 7. It's not network load balancer more performant than this application load balancer, but application load balancer is used in most cases. The reason is it provides more features. And then the classic load balancer is something all that works at both layer 4 and 7. And there is something new called gateway load balancer that operates at layer 3. And it's specific to security reasons. So anyway, you can ignore this too. Just know these small descriptions and just focus on this. Okay, let's take a look at here. OSI layer. Again, this is something, this OSI layer is how your data, so for example, whatever input text you entered is transferred over the network, how it's transformed and transferred over the network. So you have layer 7. So it's the layer that directly interacts with the user. And this is like what we see right now. You get all the information. You will see the text. And also when you send request, you can have HTTP header and you can see the header. The reason is your application operates at this layer 7. But when it comes to layer 4, layer 7 and 4 are the important ones. This layers 5 and 6 is something always there is, so you just need to know this, but layer 7 and 4 are the most important ones. And just for your information, layer 6 is according to the blog that I read. So this is responsible for decrypting data and decrypting and decompressing data if required. And there is something called session layer. So it's responsible for opening and closing communication between the local and remote applications. And for example, if a user downloads the 50 megabyte data, then this layer checks if it's done every 5 megabyte data is downloaded. So it is like do that check if it's done, and then it would open or close the connection. Okay, but the main ones is here. I will just highlight this guy. Highlighted this and transport layer. But these two are the most important layers. So what this layer does is, like it does, as its name suggests, it does the actual transportation of that data. Okay, and it receives data from the session. The session is above, and then breaks the data into smaller chunks and sends the data to the network layer. So basically, it receives data from layer file and sends that down to layer 3, and it sends data from, and then it's like back and forth. Now, when it comes to sending, it receives data from layer file and sent to layer 3. Also, when it receives data, it receives from layer 3 and sends back to the layer 5. Okay, this is how your like main protocol, main layer, that your data is transferred from A to B. Okay, you have A to B. And then, okay, this is used to transfer data between two devices, and it's connection-oriented TCP protocol. And let make sure all data is transferred. So when you are writing security groups, you notice that there is something called TCP and HTTP. Right? This is now what this is. So TCP, and there is something called UDP, which is also a popular protocol that is more performant than TCP because it doesn't make sure that the other one received the data or packets. And then there is some lower layers that, now this is layer 4. It connects end to end. If point A wants to connect point B, then it connects that end to end. Whereas this layer 3, it connects different networks. So for example, you are sending a request from MIU Internet to AWS. So basically, this layer 3 is responsible for connecting MIU network with Amazon network. That's it, period. It's not between end to end, but it's connecting these different networks. Or if you're like accessing from home network to Sakai, then there is a connection that it connects your home network with university network. But that's what layer 3 is. And layer 2 is once your request now inside your network. So let's say that you are sending a request from home to MIU, and your request is now in MIU network. And then this layer 2 is responsible for transferring data between devices in the same network. And then physical layer is like 1 and 0s, or light and dark, or high and low when it comes to frequency. Okay. Anyway, so that's here. Let's see all this now in the console. Those who are online, can you hear me?
Yes.
So and kick it out. Okay, good. So my network connection here is not stable, so it's very slow. Okay, looks like it's better now. Let's do one thing. Let's create two instances for today's lesson. And when I do so, I will do it a bit differently. I'll do it a bit differently. Here, okay, before that, I need to do something. Before launching an instance, we need to set up some things, more specifically, security groups. So for example, here, in Load Balancer, you have to define that, like, you would receive this request, let's say on port 80. In that case, in Load Balancer security group, you have to allow this port 80 from the internet. The Load Balancer is client facing. Whereas in EC2 instance, like same port is where your app is running, but only from ALB. Basically now you have security group. You have security group in here, Load Balancer, and you also have security group for each instance, right? And in security, EC2 security group, it allows access from Load Balancer, but in Load Balancer, it allows all. That's something I want to set it up first, so that when I'm launching this, I can just simply select the existing. So that's what I'm doing. So instead of this default names, like give some meaningful name, and my web server behind Load Balancer. Load Balancers. Okay, you have to give a description. Now that makes more sense than that. Launch widget something 1, 2, 3. And by default, there is nothing is allowed. Looks like I need to do one thing. Let's create load. We have to create the Load Balancer first, and then we can whitelist that in here. Let me do that. Create security group. It's security group for my ALB security group. Load Balancer. It's a security group for Load Balancer, and this is something that is TCP. TCP. Now I think you know what it's like. It's like connects those two devices end to end. It's port 80 from all. That's it. That's for Load Balancer. We had to configure this security group. Just create this. Oh, and now let's take a look at here. Not this one. Let me add one second. Our application will be running on the same port. This is fine. And here, if you look at here, now here's what you need to. In security group, you can whitelist another security group. Like we never know, in this case now, we don't need to know about Load Balancer IP address. It's hard to know. It's managed by AWS, so we never know. But AWS has this feature that you can whitelist this group. So here in the dropdown, since I gave the security group meaningful name, so I can easily find this. Like launch wizard 1, 2, 3. I have no idea what those are, but this my LP security group. That's exactly what I want. And I opened port 80 for this. From the resources that are associated with the security group. So that's it. Security groups. Let's double check once again. So here, inbound role. Okay, why is it nothing? Row. My web, not this one. My ALB security group allows from the ALB. Okay, cool. So it went through the TCP, and this is my LP, allowing access from load balancer. And there's load balancer again. This is allowing access from everyone. And now we can launch. So we set up our environment so we can launch. So my server 1 behind load balancer. And here default key pair. I don't care, so I'd be using the Stems manager if I need to switch into that. This is important because load balancer can redirect traffic to the instances created in the same AZ. So basically, I'll be creating my load balancer in US East 1A and B. So you need to make sure that your instance is running in 1A or 1B. So for that reason, I have a preference. I have a preference because of that reason. Here, 1A. And I'm in the security group, you would not create new one. Instead, you will select the existing one that we created earlier, which is here, my server behind load balancers. Select this. Okay, another new thing is the issue with previous one is like we set it into that, like once your server is stopped, you have to start your web server manually. So I would like to automate that. Okay. That I would automate that with this user data. So user data is the script that's executed when server starts. Okay, this is what the startup script is. This is where you write the startup script. I will be uploading this assignment on Sakai during break, so you can use that. Copy. That's it in here. So it's very similar to what we manually did, but instead, since we are using this automatically, instead of soda s, you do this ping bash, and then you install your web package, and then it confirms. So you are confirming all those questions, and then it's seeding to that folder, and it's overwriting. So I can rename this my server 1 behind load balancer. And then this is the script that like it starts the server automatically. It's slightly different, but the idea is same. So that should be it. Now in that case, we don't even need to set into that to configure web server. Yeah, so that's it. Let's launch it. And we will repeat the same steps for the second instance. But tomorrow, we will define this configuration once and then launch servers automatically. Okay, here. In this case, it's my server too. Let's scroll up. My server 1 behind. I'll use this name. Just let's see. And this is my server too. You have to select key pair. I'll do this. And in the edit. Subnet, in this case, I want to create this in 1B, because the other one, I think I select 1A. And security group, we will select the same security group, which is my web server behind load balancer. And then IAM role, just in case. That's pretty much all. So I repeat the same step. Okay, cool. So these are being launched. And now let's launch our load balancer. That you will find in EC2. Here, you scroll down load balancer, and then you will see this load balancers. So load balancer, there are three concepts that you need to know, but the most important concept is there's something called target groups. That's why you see this. Like you would know this at the end of this class. Anyway, create load balancer, and now you will see these options: application load balancer, network load balancer, gateway load balancer, and previous generation. Just ignore this classic load balancer and gateway load balancer. The most important ones are application load balancer and network load balancer. So in application load balancer, notice here, this HTTP and it supports only HTTP and HTTPS protocols. So those are OSL layer 7 protocol. Whereas network load balancer, it supports TCP and UDP. Those are operates at layer 4. And these are the only supported protocols. So in this case, we will be using HTTP. So let's do this. And like when you do, again, when you do something with AWS console, just take your time to go through this creation wizard. And here, this gives you a lot of information. And just take it, and then you can get some more information. So in this case, it's application load balancer. So I'll call it my ALB. Okay, if I'm not iterating, then keep all those settings by default. So I'm skipping this part. VPC, we do have one VPC, and now this is what we were talking earlier. So, and this is asking like which data centers you want to create this load balancer instance. In our case, we selected one, but we select two for high availability. But we don't want to select all 6 because it will cost a lot. So I only select these 2. And then in the previous step, when we were launching the EC2 instance, we made sure that it's 1A and 1B. And this is very common issue that like 2 or 3 students always make this mistake in the previous class. What they do is like they select 1A and 1B, but then they have an instance in 1C, and then they are just trying to route traffic from load balancer to that instance. So that doesn't work. Okay, this is the important. And security group, we will not be using this default. Just remove that and select the one that we set up earlier. It's my ALB security group. This allows all transactions. And then we have this, we are listening to port 80, so it only supports these 2. So we'll do HTTP. And now now we need to give only one information, and then we hit create load balancer. That should be it. Only one configuration. Okay, this let's do it. It's known as target groups. Let's take a look at this. So this you have this many servers running the same app. Right? This is a group of application. It's a group of servers that's running. We grouped those servers because it's running the same app. So this is also what target group is. target group or scaling group, they are the same thing. What they refer to a group of instances running the same app. Makes sense? Okay, now let's go back. Let's go back to here. Here. So we will be running instances, and this application load balancer also supports Lambda, and you can put any public IP address, or you can put another load balancer. Anyway, so load balancer. In this case, we launch two instances, so instance is fine. So we are fine with this configuration. Okay, and then here you will see a port and protocol in here. It is something I really want to elaborate on this, what those are. So first, if you remember, I'll show you in here. The idea is here, there are two connections. There is a connection from your clients to your load balancer. That's something you configure when creating this load balancer. There is another connection from load balancer to your servers. So this second connection we configure with this target group. That's what you see there. Okay, what you see. So in our case, our load balancer is port 80, and this is port 80. It looks like the same thing, but it's different. So for example, if you are hosting application on React, then it might be running on port 3000. Right? Following. And then this is port 80, but then your load balancer is making request to your server on port 3000 because this is where your React application runs. Our Apache application runs on port 80. If you have Java backend, then I think you like to choose this port 8080. Then you receive port here, and then this is the port that's your Java app is running. But when you run Java app, you can put any port. Okay, that's important. So that's what we are doing right here, this protocol. And the load balancer, this is for the first connection, listening to this port and forwarding that request to this port. Okay, so we are fine with that. And now here we have to enter this health check endpoint. So you define this health check endpoint so that it will know if these services are available or not. So for now, we are fine with this default settings. If you remember what we did earlier, like we had this something like IP address, and when we hit enter, it showed that custom budget page, and that's what this stash is. Like it's stash and there's the same. So and we know that when we make request to the root, it responds to a web page with success. And how we are evaluating success it's here. If it returns 200, so basically load balancer would make request this to your instance, to this path, and then it expects 200. Are you following me?
Request you to go to the map that you probably using, and then can you instruct us what about the log then what we do on the EC2, because sometimes like the log then we have required to bound outbound and inbound, isn't it?
Yes, we did.
Yeah, but require we like be a little bit confused about
Okay.
the role of the development.
Sure. I think I understand. Yeah, why you're okay. So basically, what's happening is, so theoretically, okay, ALB we have load balancers and EC2. So we theoretically know that load balancer empowers fault tolerance because it forwards the request to only healthy EC2 instances. And the question is how it's done. So basically, I will do these things. Okay, so it makes request to port 80 and then it returns response. Okay, this is your actual request. But before send this actual request, in order to get this one successful, you have to allow this in the security group. That's what we did. Otherwise, there is no way that ALB can connect to it. But this security group is different thing. What I'm checking feeling right now is like let's say every 5 seconds, ALB is making implicit call, and then it receives the response back. Like every 5 seconds or 1 second, it checks if that's healthy. And here you define it, the health path in the path is, so ALB will make call to this path, and then it expects 200. Only like this is the first thing it does. Second thing, once these 2 steps are successful, then your instance, okay, this is first and second, and then your instance is marked as healthy. This is a third thing. So only this instance is healthy, then now your actual request is made. So now this is the fourth step, and this is the fifth. If this is not unhealthy, then this connection will never happen. So your ALB continually check if that server is healthy or not. Make request to that health path every 1 second or every 5 seconds, and then it expects certain response. Does that help your question?
When you do the log balancer, không được cut off the picture in the C2.
Okay, let's take that online. Now this is the very last step. So let's just complete this step. Let's see how it's working, and then you would get complete picture, and then we can talk once again. Okay, so so this is success code 200, and that's it. So we defined the health check path. Here, my ALB target group. So basically, we gave it a name, and then defined the health check path and the response. And next, there is only 2 steps. Here in target group, you define the health check path and then register what instance. So in our case, we have 2 instances. One, but they both are running 1B. Anyway, it should work. So I selected the instances that I created and then register that in the target group. Now in our target group, we have 2 applications. This is the application. Let's assume that this is the same application. So create that. That's pretty much all. And when we refresh, my ALB target group will show up here. So basically what this guy is, behind this target group, we register 2 instances. You can register more or you can deregister. So basically if there is port 80, then it would forward that to this target group. Inside that there are your applications. Launch it. And then should be it. So you receive this DNS name. It takes like a couple of minutes. And then when you enter this, it should show my server 1, my server 2, and so. Okay, let's take 10-minute break and let's see how it's working.
Was optional, right?
You don't touch that mountain, but by default, all that is stuff from this album. You always focus on this.
Yeah.
So that's a little bit. Our things are these. It's been. And it's kind of, it's been kind of, it's just. But it's been.
Yeah.
Thank God for it.
And maybe, if I want to talk this, okay. Then we can go to that. There's for the, all I could, yes.
One thing is, the start concept, I send the results back, and send the results back to anyone, but that's all the responses. The main way is that the resources, the documents, here to tell my investors about nothing, needs it to, on the law, nothing, this is the. This time, you just discrimination on this time, there's no direct connection. That's the reason why we put on the security. Or the what is the problem? It's sometimes one is when this is a new type of snow, so what's without action, like it can be done. Not the aim, if you're not fast, I found the no one backs down. No, it's no. Oh, very good. Okay, I got it. Okay, do you remember that? Like, I added the condensate, but it didn't show up. Got it. And then that gets you this.
Yeah, when you be full before security.
Okay, let me fix my back. Looks like I got.
A small request, like, is it possible to do it like code along? Because sometimes if you get too fast, I can't catch up with you.
Sure, yeah, that's basically all for today.
Like when you like typing and you know,
Okay, that's what afternoon session is. Afternoon session, like we are.
It's called chicken salad. The unwanted is what we have good cheese on what doesn't.
yeah, I saw them. Like, but even you are. No, she was on. Yeah.
Usually, and yeah.
This policy was one. I think it was also. We can have more. Yeah.
I think if completely that level we can. I think. Yesterday, I did in class, my I campus. Yeah. Yeah.
Okay, so yeah, you can start. Not sure. Okay, so I start creating all those resources, but it's unhealthy. So that means if we hit that load balancer URL, it will not respond because there is nothing that load balancer can route that traffic to. So it's common. Like when you do to this lab, you would get this error. So let's debug this together. There are only two reasons that why it's unhealthy. So first reason is there is something wrong with the security group. Check your security group on your web server. Because this is the connection. This is unhealthy because if you look at the picture, so AFB is making API call and see if it's healthy, but somehow this EC2 is not returning 200, or maybe it's timed out since there is nothing. So it time out because of these security groups. And yes, one student noticed that I was adding one rule, but then I added a rule in outbound rule. So I thought that I was adding that to inbound rule, but then I did that in the outbound rule. It's like never touch this outbound rule. So by default, it's fine. In security group, the main thing you focus is like who can access to your resource. And I corrected that. Like it was incorrect. So I corrected that and reverted back to default. So now it's looking good to me. Like if there is a request, then it would process and return the result. This is for our web server. And it also allows the request. So this is here on port data is from my security group. So I don't think there is any issues with security group. So let me check this. Like we have to make this healthy so that it will work. I just realized one thing. Once it's unhealthy, you corrected something, you made some changes. So for example, here, I corrected the issue. I corrected the issue and fixed my security group. In that case, you have to deregister this yourself manually for now, because we registered this, deregistered that, and then register it again. You have to do this manually since you don't have any auto-scaling group. So once you have this auto-scaling group, it will do that work for you automatically. If it's unhealthy, then it will remove that service itself and then add new one from the template. So for now, it's a bit manual. Again, if you get this, then there isn't. Yes.
What did you actually change in the inbound?
In outbound rule, I just kept it by default. So previously, what I did is I thought that I was making changes to this inbound rule, but I wrote this rule in the outbound.
And you just removed it.
I just removed this and reverted back to default. In the afternoon, we can do it together, like a step, like pair programming. I will do it. You will do the step. I will confirm that if you have completed that. So that's something we can do. Yes. It's like, yeah, protocol is TCP. It's port 80 means it's HTTP. So yeah, don't mind this one. You can. So this port 80, it translates to HTTP. And HTTP runs on top of TCP. So HTTP is TCP. Okay, so anyway, so don't mind that. It's not, that's not the issue. The issue was I just put this inbound rule as outbound, and then I just reverted my changes to default. Yeah, draining. Okay, cool. There should be nothing in there. It's draining means, like, for example, if there are some active connections between your instance, like there are two ongoing connections. In that case, like it waits all those connections are terminated. But that's basically what draining is. Anyway, yeah, there are some. There are, I think, 5 status. So draining means it's being removed. Initial means it's making the health check call. Unused means you associated an instance, let's say for example 1C, but then your instance doesn't have any node in 1C. In that case, you get this. Unhealthy means it's done with the health check and now it's unhealthy. Anyway, so let me register them once again. Here. So we fixed the bug. We register them. Register pending. Okay, fingers crossed. I hope this time it should go. And there are some things. So here, Pat is here, expected results at 200. And it would make that call every 30 seconds. And then if there are 5 successful responses, then it will mark that as healthy. So basically now we have to wait about 2.5 minutes. Right? Follow this. You can change this. You can reduce this number, reduce this healthy threshold. And yes.
Sending requests every 30 seconds doesn't make it
More expensive.
heavy or easy to the McDonald's. Is there any way we can expand the polling interval? Because it seems like a lot.
Yeah.
Sending 30
Yeah, I also agree with that point.
Is there
That's
any way we can configure it by ourselves or is it default?
but this is how you check the health of the targets in loudness. The only way is like this way, this naive way. Like me. So yeah, I agree with you. like it will make this, but this will do it. It will send some transactions to your server and make that heavy. I can reduce this. So yeah, you can reduce this.
It's just a simple GET request.
Just GET request this.
I mean, it's very, should be really fast. It's not that fast.
Yep, that's why this timeout is the. It makes request, and then it waits the response for 5 seconds. If it takes more than that, it would mark that as unhealthy. But then even if it received the response in 1 second, it would wait for 30 seconds before making the second response, second request. So initial, okay, let's keep getting unhealthy. Why is that? Load balancer. Security. My AAV security group. And then in EC2, for my server one, security, my server behind this, and it allows TCP sources. What is this? It doesn't look right.
I think it's really unhealthy.
Yes. Wait, there is one, like, when I was doing this configuration, I messed up some things. So this server is associated with this security group. And it doesn't look right to me. Inbound role. Okay, this is correct. Behind loud plans. Now let me do one thing. This is for my web servers. I would edit this and one more. So we checked the security groups and there is no issues. This web server security group allows security group of the load balancer. I wonder if my web app is running, if that user script was correct. So for that, I'll allow HTTP to all for now, just for debugging purposes. Once I debug it, then I will delete this. So I'll do this. So this one. And this is another founded. Okay, should be it. Let's grab this. It should respond. Otherwise, cool. Okay, that makes sense. So now we have to fix that. Like it. So when it does this, like you don't receive this 200. Instead, it seems like something different. So let's fix that, and then it should be okay. So that means actions. You can edit user data in here, but I am not sure it will take the changes immediately. What I am planning to do is just switch into that and start some. So there is something wrong with this guy. Where did I? Yeah, like this command is supposed to start this. Okay, there is something wrong with this script. Okay, there is something wrong with this.
Yesterday, I found that no www folder was not created in EC2 instance.
Sure.
We connected via session manager.
Yeah, let's do that. Yep. doesn't show up. Okay, this one I didn't even associate it in it. The other one I hope I did. So, okay, cool. This one we can. So we have this connect.
Professor,
Yes.
my camera is on all the time, and someone is asking me to turn on my camera. I don't know why. It's already
Sure.
on.
Okay, got
Mine
it.
is on all the time.
Sure. Okay, so let's check CD. Okay, let's do that. Yeah, so that's we would need that. And CD. Yeah, I would just wanna know like which part my user script failed. So CD, is it var? Cool. So it didn't even install the package. What happened? Okay, we'll figure out this later.
Then do it, man.
Yeah, let's do it manually. Install. No, just install. Okay, now we should be able to do that. Index. Wait. The server behind AOP.
Server 1.
Sure. I think I already. It was server 2, I think. Load balancer. I'm also planning to run this server behind network load balancer. So let's just behind load balancers. Yes. But okay. Now service HTTPD. Cool. It should be it now. Let's debug. Cool. It's working. And now we are finished debugging. We don't need this anymore. Like we found out where the bug is. The bug was user script didn't work. And we even checked it like where the user script failed, and it like even failed in the beginning. We know all the cause, so just for now, remove this. And now monitoring target groups. That's what we've.
Okay.
Cool. The other service, like I can't switch into that right now. I didn't associate that with IAM Pro. Let's do it later. Okay. So for other server, what I can do is I can use the existing server. Let's do that. Instances. I think one of them should. I think this one works. Security. Yep. Let's run this behind load balancer as our second connector. Cool. So for this guy, go back to here. So we have to start this. Sure. Okay, here, register target. Let's register this. Here's sudo. That is service HTTP start. Okay, this is something we configured earlier. So now we have the application running, and this one was, I think, this one. So the included is. So yes, I will do that now. Okay, we started that. This is actions, security, change security group. Maybe not this guy. My web server behind. Okay, we changed that. And also let me change its name back. My web server 3 behind. Okay. Makes sense. Everyone following? Okay. Oh, now we have 2 healthy instances. And now let's test this out. Now, when we deploy, in real life, we had that containerized applications at my last job, and that runs behind exact same load balancer as you see here. And when we deploy, they replace these resources with new resources, with new code. And what we do is like we just keep refresh this page. First it goes to initial, and we make sure that it's healthy. If it goes unhealthy, then that release was not successful, so we have to debug. That's like big issue. Anyway, so it will send request these two, but it will not send any request to this guy. Okay. Again, your load balancer is functional only when there are healthy targets. Load balancer. My server behind 2 is something we manually did, and I expect the other one. Okay, it's not showing up. The reason is it's because of the algorithm. So basically, there are some algorithms. So routing algorithm. So there, the first routing algorithm is it's round robin, and it's load balancing. It's like simple load balancer. So basically this guy. So you have load balancer, and then you have server 1, 2, 3. And then when you receive a request, when you receive this request, it's first processed by this guy. And the second request is processed by second. And third is processed by third. And the one it reached out to the limit, and then the fourth request, it will be processed by the first server again. That's what round robin is. And there is one more thing, bit advanced, that list outstanding request. So what it does is it chooses the instance that receives the next request by selecting the instance that at the moment has lowest number of unfinished requests. So basically, so now same thing, load balancer. 1, 2, 3. 1, 2, 3. And here, this number 2 is serving 5 requests. And this one is 1. And this one is handling 10 requests. In that case, this list outstanding algorithm will choose the server 1. When there is a new transaction, it will choose this one. and then now it's sending two requests, and you receive another transaction, it will choose the same message again because it only have two unfinished requests to make it through. So that's what those algorithms. Make sense? And now since this guy is, it's okay, now it's refresh. Okay. If I keep refreshing it, then it okay. We did this on purpose, right? But like think of it, I did this on purpose, like to different contents to show you like it's sending requests to multiple servers. Our assumption is just think this as one application running on this. Okay, it would get much better when you actually do it, so we can do it together in the afternoon, like step by step. What else? Let's go back to here, load transfers. There's some more things. Application load transfer. Currently, so it supports two protocols, HTTP and HTTPS. HTTP is port 80, and you can add another listener listening to port 443. And let me show you that. Okay, it's like taking too much time. So when you have that HTTPS, when your load balancer is listening to HTTPS, you need, that means you have a certificate. You have a certificate, and where you put your certificate is on this listener. If you notice here that there is default as a certificate, like if you have a certificate, then you put that on the listener. Previously, like through this approach, like I understand like this lesson is getting trickier. So yeah, we build that and then we deploy that on server, something called server. And we do everything on only these two components, like use configure certificate or that course, like you do everything in the application code or in the server. It's two components. It's easy to understand this architecture because it's just like this is only one server, right? That's it. But in the cloud, as you see here now, there are many components. Like in one server, you had image, EBS, security group, and so on, like many components. So that's like it's what makes it challenging to learn in the beginning. But as time goes, it gets easier. So here I drew this. There are, and again, so this has this many components. It has many advantages. For example, configuring HTTPS on your application or your server, it's a lot of work. A lot of work. I think some of you maybe tried that. It's hard work. But with AWS, with the advantage of this many components, configuring the certificate requires one click. You upload. You don't make any changes to your code or existing server. You just go to this listener, when it's called listener in your load balancer, and upload your certificate here, and that's it, period. It's one click and you actually the result, and without making any changes to your code or changing any control of the server. So this is where you upload your certificate, and in ALB you have, so it operates at layer 7. It provides more features. So one of the feature is, let's take a look at here. You have something called listener rule. Listener detail and rules. Okay, so currently it's naive that we only have one rule, the default rule, that sends traffic to our application. In real life, now let's take a look at here. At my last job, basically what we did is, what people normally do is, so we do have ALB for sure, or ALB. Everyone is accessing ALB. And then behind this ALB, currently what we have is, it's app one or microservice one. This is what we have. This is the default role. Default. Now maybe requirement is you need to manage one more microservice. In real life, one team manages multiple microservices. My last job, we managed about 12 microservices. And those different applications you run behind one load balancer. Now, we want to run application 2. Go ahead, you can do it. You can do it. For that, you can write rule. And then this is app 2. App 2 is basically its target group 2, right? This is target group 1. Okay, the bottom line is behind load balancer, you can run multiple applications. And how you do that is by writing this rule. So let me show you how the rule looks like. Manage rows. Okay. So currently we only have one row. So here, let's add new row. And when you add that role, you can capture this information from the request. For example, let's capture the path. The path is equivalent to application 2. Okay. And then in that case, I will forward that request to another target group or another application. Okay. Not only that, you can again, like you can capture header and all those things. So basically, then what would happen is by default, it would send request to my app 1. But then if I do app 2 in the here, then it would send this request to another group of applications.
So app 2 would have its own load balancer.
It's the same load balancer.
Can you explain this one?
Okay. So all the requests coming to one. So basically the bottom line is in load balancer, it listens to port, like port 80 or port 443. The basic load balancer receives all the requests from clients for your applications. For your application. So behind load balancer, you can have multiple. You can have multiple applications. And how you route your request is based on these rules. For example, if rule 1 is equivalent to, so this is load balancer. If we do here app 2, it will send the load balancer will listen to this. Load balancer receiving this request. App 1, 2, 1, 2, 3. Load balancer receives it, and then it captures this path, and if it's app 1, send to app 1. If it's app 2, send to app 2. Default is the default one. Like if there isn't any rule, if no rules match, then it forwards as equal to that.
If there is no time available on
Yes. Yes, but yeah, exactly. So here you're writing rules in here. Insert rule. It's path based. Like here you can write this route. Maybe let's insert one more rule. Yes. In this case. Okay. let's say, okay, it's my last, so okay, behind load balancer, that doesn't mean that you have to run many applications all the time. Like it depends on your use case. If your team manages only one application, then you can have one default, like we just did. Or at my last job, we had 12 microservices. And then we run all those services behind one load balancer. And then, for example, if there is a request called, for example, then there is load balancer. And then in real life, we had a service called data service. It's a service that works with database. And then if it sees this request, if the request has this in the path, then this request is redirected to that application. If it's something like admin UI, then this will show the admin UI that's written in like React.
We cannot use in multi-language.
Yeah, obviously, yes. Doesn't matter what language it does. As long as like what you would do is like in the target group, you would write that health check endpoint.
In this case, we can call it something like redirect or not load balancer.
Sure. Yeah. Obviously, yeah. That's a great question. So if it's app2, then instead of forwarding to another application, what other rules you can do is you can redirect to some other link, or you can return just response. This is like two other things that you can do. Once this condition is met, then you can forward to another application or redirect user to something else or return fixed response. That's all about application load balancer. Application load balancer here. In terms of application load balancer, we can have two listeners, HTTP80 or 443. And in one listener, for example, in port 80, you can write multiple rows. For most cases, people use these rows to redirect requests, route requests to different applications. And then there is a listener. It's listening to this part. And then here you can attach certificate. And if you need certificate, then you can get one from AWS for free. Listener rule, we just discussed if you want to, you can run multiple applications behind one load balancer. And in that case, you might want some rules based on which condition you want to redirect to that. That you can do with rules. And here is some more explanations, like the examples that I gave you. And in target group, this is what your application is. Right? In target group, your application is running. And here target, it with target group. So there are two connections. And there is one thing to note here is, let's talk about this and then we can solve it for this. So you are making a request in here. And this is client is making a request to load balancer. ELB. And this is making a request to EC2 instance. Okay. There are connection 1 and connection 2. In ALB, you receive the request, and in this case, the source IP or the client IP is your IP. So in our case, for example, my public IP. I do this. Okay, this one, 206. 209.152 and so on. You got this, right? It's the source ID because I'm making the request. But your application is hosted on EC2. In this case, your application will not see client's IP address because in this case, source IP is ALP IP. You might want to do some processing based on this. Like you want to process client IP in your application. How do you do that? So the answer is still in the header. In the header, you will see client IP, and this is like 29152, and just for your information, here and here. Understood. That's fine. Then it's connect. In terms of NLP, NLP is a bit different. So you have here, NLP is this way. NLP is it network load balancer. It's more performant. As you see here, there is no dash in here. That means your EC2 is like default, you can change. Source IP is still 209.152. This NLP just forwards the request by default. There are some slight differences. This one, this ALP box is looks like proxy. So there's a connection. It terminates on this ALP, and then there is new connection. But in NLP, it's just pass through. It's just passing this guy here. And now our task is second. So first task is I just demonstrated run servers behind load balancer. Your second task is second and last task is we want to practice this NLP, right? And one thing we need to solve is on this EC2 instance, I want transactions only from NLP. Like this EC2 security group, I want to allow transactions only from NLP. But then here, what you see is source IP is still client IP. So how do you do that? So that's the challenge. That's the question. So how you can do is you can change one configuration there. And there is one configuration in here. If you scroll down, reserve client IP address. This one is selected by default. So if you deselect that settings, then yours will look like NLP. NLP, it looks like ALP. So here is it. And now you can whitelist this guy now. Now source is changed from client to NLP. It looks like just one simple checkbox, but it plays a big. One more thing, in NLP, it operates at layer 4. It doesn't have features like path-based mapping, or you can't run any Lambda code. You can't run them behind NLP. It's not possible. And you can't even have security group. Here, there's no way. There is. So what we did in ALP is we whitelist security group of ALP in EC2. But NLP doesn't support security group. So how do you do that? Is in here. Now your NLP EC2, they are inside your VPC. And when you launch this, you select those ASICs like 1A, and 1B. 1A and 1B. So this 1A, 1B is essentially like those subnets. 1, 2, 3, and you remember it, right? That center is associated with the subnet. So basically, you will whitelist that entire subnet in this EC2. Okay, so I will demonstrate this NLP in the afternoon for 30 minutes. And then 2 p.m. to 3 p.m. we can code together. So we have 30-minute lesson in the afternoon. Any questions? Yes.
What about if we like to have servers that can listen to other ports that are running the network? As you mentioned previously, is you can run Java application that is into a public or it's Node and it's running drives 3000.
Yes. In the target group, you create target group, one target group for one application. So let's say so for example, you create a target group for React application. In that, you will configure that 3000. If you have Java application running, then it's two different apps. You don't run this in one target group. You have to create one for that, for React application. So in that target group configuration, you put 3000. That your application is listening 3000 or 880, right? But load balancer is always listening. It will always listening to port 80 or port 3.
So can we restrict the application to listen to specific domain rather than specific IP address?
For our application, yes, that we do with security group, right? Security group port 80.
And that's some domain that is allowed to make requests to the server.
Okay, listening. The first thing is your application doesn't listen to your load balancer. Like a load balancer is making requests to your application, so it's not listening. It's load balancer is pushing data.
Let's say one of the microservices is making requests to some server to different clients. It's some data.
Yes.
Can we allow that?
Send data you receive. That's different, I think. So for example, here, that's not related to load balancer, I would say. So your EC2 instance is making third-party API call, right? Third-party API. And then you receive the response. Here. The first thing is this third-party API should allow your EC2. Your EC2 will have like one sort of IP address. And then it sends the response, and it should, the security group, you should whitelist that. But it's like a bit different. It's not related to load balancer you created in here. It's between your server and let's meditate. Sure.
You can leave it here first. We have recording in the afternoon.
Afternoon. Yeah.
30 minutes.
30 minutes.
So we can leave it. Just 1:30.
Okay. Sit comfortably and close your laptop. Close your eyes. Stop thinking of it, Matra. Take a caption instead. Slowly. Yes.